Welcome back to the workshop. We want to continue taking a look at mathematical induction with an example of a proof by induction. So we want to prove that n factorial is greater than 3 to the n for every integer 7 or greater. So we want to write a proof by induction again. We begin by indicating that we're beginning a proof, and then we identify the statement that we want to prove. And the statement in this case is that n factorial is greater than 3 to the n. And our base case would be when n is equal to 7. Okay, so n naught, our smallest possible value, is 7. From here, we perform our base case. We show the base case is true. So we let n be equal to the smallest possible value, 7. Here, what we can notice is that n factorial is 7 factorial, and 7 factorial is 5,040. And here, if we wanted to produce a string, we could do that. We might say to ourselves, do some side work and observe that 3 to the 7th is actually equal to 2,187. So I have n factorial is greater than 3 to the n when we're letting n be equal to 7. Right? So n factorial is 7 factorial, which is 5,040, which is in fact greater than 2,187, which is in fact 3 to the 7th, or 3 to the n. So thus, S of 7 is true. So since it's true for the base case, we move on to the inductive step. In the inductive step, we want to be able to show that it's always going to be true for the next case whenever we have it's true for one particular case. So we assume that S of k is true for k greater than or equal to 7. Okay, the smallest possible value that S of k could be true for is 7, because that's base case, that's the smallest. Then, if S of k is true, which is what we're assuming, then k factorial is greater than 3 to the k, because that is exactly S of k. That's our statement for k. For n equal to k plus 1, so now we're going to show that S of k plus 1 is true. We want to show S of k plus 1 is true. So for k plus 1, I want to consider k plus 1 factorial, because I want to show that k plus 1 factorial is larger than 3 to the k plus 1. That is our statement for k plus 1. Well, k plus 1 factorial is k plus 1 times k factorial. Excellent. Well, because I know that S of k is true, or that's what I'm assuming, then I know that k factorial is greater than 3 to the k. So if k factorial is greater than 3 to the k, then I can replace k factorial with 3 to the k and say that what I end up with is a little bit smaller now. So k plus 1 times 3 to the k. This thing is greater than that thing. How does that help us out? Well, this is greater than 3 times 3 to the k, since k is greater than or equal to 7. Since k is 7, k plus 1 is at least, or sorry, k is at least 7, k plus 1 is at least 8. So if I replace it with something smaller, then I'm getting something smaller. Okay, 3 is definitely smaller than whatever k plus 1 is. So this thing is in fact larger than that thing. But that thing is the 3 to the k plus 1. And now I have exactly what I want. K plus 1 factorial is larger than 3 to the k plus 1. Thus, S of k plus 1 is true. So the inductive step holds. The inductive step is true. Therefore, by the principle of mathematical induction, the claim is true, or the statement is true, S of n is true for all integers greater than or equal to 7, right? The base case. Excellent. Indicate the end of our proof with the square that has been filled in. All right. So again, that's another example of a proof by mathematical induction. That's all I wanted to share for this video, so we'll pause there. I would encourage you to review this proof and review the previous proof if you're not quite sure what's going on, and review the proofs that are in the text, because the ones that I've provided here are not the same ones that are in the text. And of course, you could search for additional videos on proofs by induction. I am confident that there are many. But I'll see you guys back here in the workshop for a little bit more, not quite another example yet, but a little bit more involving mathematical induction, and then a little bit later, another example. So I'll see you guys soon.